Hello, I want to have a look at KV331 SynthMaster, which is a polyphonic synth. It's very cheap and it's capable of doing quite a lot of stuff. We can do frequency modulation, subtractive, additive, wavetable, and even some more esoteric types of synthesis. It looks a little bit like this and it sounds a little bit like this. To get your hands on SynthMaster, you can head to their website and buy it for $64, which is just under 50 quid, so it's really super cheap. This is just going to be a really brief tutorial looking at the front panel. If you want a more in-depth look, I'm going to link to SadowickProduction's YouTube course on this, which is really good and very informative. So SynthMaster is comprised of two identical layers, and each layer has two oscillators to it. We can control the volume of those layers here, we can bypass them. We can control the overall volume and tuning of the synth there. In the settings page, we've got our preset quality, which will affect CPU and various other things. Underneath this tab, we have our modulation matrix, which we'll look at. And we've got a lot of other sort of things, which I'm not going to get into today. So let's start off by going New, Reset, Preset. And as you can hear, we just have a simple sawtooth there. Both layers can be selected here. At the moment, they're identical. We have control of our four LFOs here. We've got some global effects such as chorus, echo, reverb, and we've got a patch browser, and we've got a preset page where we can write our own presets, metadata, and etc. Let's start off with layer one. So we're just looking at oscillator one at the moment. You can turn on our second oscillator here. The oscillators can either have phase or frequency modulation applied to them. We've got two filters, which can be run in series, parallel, or one per oscillator. And we've got our basic effects, which can be turned on there and edited in these screens, which we'll look at in a bit. Other things to consider here, we've got how this layer works, whether the layer is polyphonic, monophonic, or legato. We're not going to get onto the legato today because that involves envelope retriggering. We can determine the pitch bend range of our layer and how many unison voices it employs, which won't sound too different at the moment because in this bottom page here, or bottom panel I should say rather, we have things like unison detune, the unison pan, and the voices pan. We've also got glide, which some of you might know as portamento, and I'm going to switch those voices back to just off for now. Bear in mind the unison voices for this is independent of the actual oscillators unison voices, which we'll get to right now. So our oscillators have lots of different controls available. We've got 4 different modes which we can run in, plus an audio input. Let's stick with oscillator 1 for now. We've got control for that oscillator's volume. Something which sounds a bit like a low-pass filter, but I suspect to be just reducing the number of partials. I haven't checked in the manual, so I don't know. And we've got the start phase of our oscillator from 0 right the way through sort of like 90, 180, etc. That only really makes a difference when the oscillator's phase is restarted on gate high, which it is at the moment. If we want it to be free running, we can do that. And again, that won't make a huge amount of difference until we increase the number of voices for the oscillator. So if we put this up to 8, you can hear sort of flangey effect almost, because lots of detuned, well, I say lots, 8 detuned voices are being restarted from 0 degrees. If we put that on free, you can hear a slightly different sound to it. The amount of detuning can be controlled here. The individual oscillator's pan position and the amount of stereo detune applied to the voices. If you double click on a parameter, it will go back to its original position. The oscillator's pitch can also be controlled there. Oscillator 2 is identical, except we have this sync button, and what this sync button will do is restart the phase of oscillator 2 to oscillator 1. So if we sync that, turn it on. Let me turn the voices down to 1. Now if I change the pitch of oscillator 2, we'll get a very sort of typical oscillator sync sound, which some people like. The oscillators have all these sort of usual suspects for simple subtractive synthesis: sine, triangle, square, sawtooth, pulse, noise. But what's really cool about this is we have all of these other sampled waveforms from various sort of like big hitters in the synth world: ARP, Buchla, Doppler, Fairlight, Korg, Moog, Oberheim, Odyssey, which I always thought was an ARP synth, so I don't know why that's not in the ARP drop down. Prophet. In the Rhodes, we've got the Chroma and Polaris, very sought after cool 80s synths. We've got tons of Roland ones, and from the sort of more digital end of the spectrum, we've got Waldorf, and then we've got some of the Yamaha CS series synths, which are really quite sought after polys. We can also import our own WAV or AV files to create our own sampled cycle waveforms. So that's just really cool. You know, we've got all of these other different harmonic potential. In the basic mode, there's not a ton of stuff we can do. This is just how a standard subtractive synthesizer works. Let's drop down to our next mode, which is additive. And what we've got here is 8 different versions of our oscillator, which can have their own individual volume. Let me just turn off oscillator 2. Here we've got the first 4 harmonics. We can pan those around, detune them slightly, and also change their tuning. So we've got 2 options. We can either use integer multiples, and that's what harmonics are really. They are integer multiples of our fundamental frequency, and we can also change them by semitones if you wanted to do so. What's really cool is all of these 8 sort of versions of our oscillator, if you like, can have their own envelope settings applied to them, so you can do some really quite cool almost FM-like stuff with this. We can also change all the waveforms of those individual oscillators, and we can invert their polarity by 180 degrees. So it's rare to see additive synthesis so simply displayed and so flexible. So I'm a really big fan of that setting. In the wave scan page, we have something which users of things like Massive and Serum might be more familiar with. What wavetable synthesis is the ability to scan through a series of different cells. What I'm going to do just while I'm talking is randomly load different waveforms into these cells. So if we have 2 cells, one with a sine wave and one with a triangle wave, when the wavetable read is in the first cell, we'll hear a sine, and when it's in the other cell, we'll hear a triangle. When it's morphing between the 2 cells, we'll hear the harmonics of the triangle wave be blended in very slowly. Now, when you use more complex waveforms, like what I'm assuming these are, we can hear some slightly more interesting sounds. I'm just going to drop the octave down on my keyboard a little bit. Now when I move this wave index through, you can see it moving through the different waveforms. You can determine the number of cells being used here. So really quite a kinetic sound. So yeah, users of Massive and Serum would be familiar with this type of thing. When you combine this with the fact that you can have your user waveforms that have been loaded from WAV files, we've got really quite a lot of potential there. The next mode is this vector, where we can make some really quite awesome ambient drone type sounds. All of these waveforms are again editable, and you can again change the integer of the semitone tuning. There are 2 ways we can run this, either in 1D or 2D. So this vector synthesis, so far as I'm aware, is akin to the sort of Dave Smith instruments from the 80s, like the Yamaha SY series, and I think some of the Prophets, and in the 90s things like the Korg Wave Station. So really excellent for those constantly evolving type sounds. Let's just go back to the basic waveform and load a sawtooth, and we'll have a look at our filters. The filter can be switched on here. We can also boost it a little bit. We've got 2 algorithms, analog or digital. The main difference being digital has predetermined slopes, either 12 or 24 dB per octave, whereas in the analog we have this slope control where we're almost doing no filtering at all to something a little bit steeper. All the usual candidates you'd expect here are, the filter cutoff position, some quite squealy resonance, the volume of the filter, which is quite interesting, and the amount of keyboard tracking applied to it. The filters also have a sort of pre-distortion circuit and a limiter. The limiter is really useful when we're using high resonant values. We've got lots of different algorithms here: low, high pass, band pass, something called a band stop, which I'm not super familiar with, but it looks a little bit like a notch when the resonance is down. Low shelf, high shelf, peak, a multi-mode filter, which can go between a low band and high pass, similar to the new filter circuits in Ableton Live. And we've also got this dual filter where we can have two independent filters, which users of FM8 would be familiar with. I'm going to stick with the standard low pass filter and just bring the cutoff down and turn the resonance up a little bit. Notice it self-oscillates quite easily. Let's turn the boost off as well. Wrong button. Yeah, so watch out for that. Let's have a look at the modulation matrix. What you'll notice is that layer 1's voice volume and layer 2's voice volume is being multiplied by ADSR envelope 1. Our modulation is in this bottom right quarter, and we have 4 envelopes and some other things we're not going to look at, such as multi-stage envelopes, key scaling, and LFOs. We have a target and a source, so let's select the target as layer 1, filter 1, cutoff, and we'll select the source to be voice envelope 2. And if we go to envelope 2, we'll drop the sustain, increase the decay a little bit, and as we increase this bipolar rotary, you can hear a sort of pluck type sound. Now the modulations can either be added, as I mentioned this is bipolar, or they can be multiplied, and you'll get slightly different results depending. If we go back to our wave scan, we can see that it's remembered at least the from 9 through to 16 of our waveforms. The reason it's changed 1 to 8 is because we changed modes. So if we were to go target, layer 1, oscillator 1, wave index, and we were to go source, let's go voice envelope 3. I'm just going to turn the filter off for now. I'll turn the attack up. We can change the curvature of this from linear, exponential to logarithmic. We can hear, let's turn the sustain down as well. It's going through all of these 8 sine waves and then through the sort of more esoteric waveforms. Last thing I want to have a look at is the effects section here. We have distortion, a lo-fi, an ensemble, and a phaser, and an EQ. They can be turned on and off here and edited here. So the distortion sounds like a typical distortion. We have a pre and post EQ, which is really nice. In the FX2, we have a digital distortion where we've got sample rate reduction and bitrate reduction. I'm just going to turn the wavetable modulation off. We also have an ensemble here, which is similar to the string synths made by Roland in the 70s. And in FX3, we have a basic phaser, which won't sound like much at the moment, and then we have an EQ. As I said, this is really just a brief overview of the standard functionality in this synth. There is a lot more that it can do, which we might get to in later videos, but for now, that's been all. Thanks very much.